Ladies and gentlemen, welcome. Thank you for coming. My name is John Peters. I have the pleasure of directing this semester's Schulman Seminar on Elemental Media, and it's a great delight to welcome you to the Whitney Humanities Center and to hear our speaker, Professor Paul Edwards, this evening. Paul N. Edwards is William J. Perry Fellow in International Security at Stanford University and Professor of Information and History Emeritus at the University of Michigan. I hope you're not watching me. You should be watching this completely spellbinding animation here. He's the author of A Vast Machine, which, let me get the subtitle properly. Computer Models, Climate Data, and the Politics of Global Warming, a monumental history that I recently had the pleasure to reread for my class, and the Closed World. It's a Cold War, that's where the interference is coming from. The Closed World, Computers and the Politics of Discourse in Cold War America from 1996. Also the co-editor of a book called Changing the Atmosphere, Expert Knowledge and Environmental Governance from 2001. In addition to a wide array of fascinating and marvelous articles which have had a huge influence on me and many people in this room. He's one of the leaders in the infrastructural turn, which is leading to so much lively debate in recent years and brings together scholars and scientists in the humanities, social sciences, and STEM fields, especially via his work on knowledge infrastructures. Our lecture series, as I mentioned, has the theme of elemental media, and Paul Edwards was at the top of my list. In him, you can see how seamlessly a historian of computing became a historian of climate science, and the way his career encompasses data machines and global weather, global climate, is a lesson in how we cannot think or act, whether locally or globally, in our environment without media of various sorts. There are no data without models, is a famous point of his book, A Vast Machine. But he also makes the point in passing, one that I would like to emphasize tonight. There are no data without media. Let me also note this Wednesday, from 12 to 1 in Kroon Hall. Let me get this right as I'm blind. Burke Auditorium, Kroon Hall. Professor Edwards will be speaking on time and risk in climate knowledge. So there'll be further opportunities. But as for tonight, please join me in welcoming Professor Paul Edwards.
Thank you so much. It's been really a great pleasure to be here for this visit with John and his wonderful class, and some of you are here again to see me again. Don't know why you'd want to do that, but there you are. So today, I'm going to talk about the creation of climate knowledge, a bit about how that works, and then talk some about controversies in climate science that have happened in the last 20 years and kind of where they have left us today. I need to do a little bit of setup here. The setup involves a book that was at one time very well known called An Evolutionary Theory of Technological Change by Nelson and Winter from 1982. So this book was about organizations and how they work. And their paradigm for an organization was a factory, so like an automobile factory. Big organization, lots of moving parts, lots of different departments and aspects. And in one of the chapters of this book, they talk about routines as memory, truce, and target. And here's what they mean. So memory for them is, how is it possible that any organization kind of maintains its identity over its long lifetime? People come and go, but the organization keeps doing what it did. And one answer to that is that they develop routines, and the routines are taught to people, and everyone knows them. So a new person comes in, and they learn the routine, and they just keep on going. And to some degree, those routines often become embedded in technology. That's what we call automation. A second point they make is that there are truces in any organization, and that routines exemplify them. That is, you've got a process and it keeps rolling even though there are conflicts. Labor management, people have their issues with each other, all kinds of things. And there may be defiance, there may be laziness, there may be people missing steps, but because the routine is there, the organization knows how to fill in those blanks and keep things rolling even while while those conflicts happen. And the last point they make is about targets. So their idea is that routines of one sort become the paradigm or the pattern for routines of a new type. So the organization starts to do something new, make a new kind of car, for example, and it takes the routines that it had been using and now applies them in a somewhat different way to the new thing. All that seems pretty straightforward. Now let me apply this a little bit to climate science. So in climate science, one of the major things that goes on is memory. That's how we know that's what climate is. It's like the history of weather over very long periods of time. So one thing that has to happen is that we have to keep that knowledge. I mean, you could call it data, but there's more to it than data. And as I'll talk more about in a minute, one thing you have to do with it is adjust it, because you learn new things about how old information was made. So you need to change it. But in any case, you keep a memory of climatic history. There are also truces in science, and that's what happens when a scientific routine develops and continues despite conflicts over things like standards, units of measure, the meaning of a particular phenomenon, and so on. And then there are also targets. And a great example here is that when satellites first became available for weather information, satellites do a much different thing than a weather balloon that kind of flies up through the atmosphere and measures points along a line as it rises. A satellite is seeing a gigantic volume of air underneath it and measuring that as a whole thing. So the weather balloon can take measurements at points, but the satellite is just seeing one thing, radiance at the top of the atmosphere, and that has to be disaggregated into all the parts of the structure below it, and it's also measuring a big volume. So the satellites come in. What do you do with this data, which they have no way of processing yet in a weather model? And they say, well, we'll turn it into radiosonde data. We'll make it look like radiosonde data. So they use various algorithms to translate it into basically points along a line. Now today they've developed better methods of handling that kind of data, which is so different, but that was one way in which a routine became a target. Okay, I'm also going to be talking about target today in a much different sense, that sense, something to shoot at. Okay, I forgot I was supposed to stand behind this microphone here. So this is also a little bit of background. I'm going to be talking about knowledge infrastructures, and what do I mean by that? So I'm talking about something that is mostly taken for granted, like weather forecasting. You probably don't know or care about how weather forecasts are made. You just look at the weather forecast and use that to think about your day. And you know that they're not perfect, and it's not going to always turn out that way. But still, if the weather forecast says it's going to rain, you're probably going to take an umbrella. So these things are made of people and equipment and institutions. They generate knowledge about the human world or the natural world, and it's routine, it's reliable, it's something that people accept and just use. So examples of these things, there are many, are the Census Bureau, which counts our population and its characteristics, the Centers for Disease Control, the Bureau of Labor Statistics puts out statistics every month, and Wall Street goes nuts, reacting to those statistics, but it doesn't, for the most part, question them. It just uses that information. And same thing with this piece, which is these two pieces, which are about weather and climate. Okay, so here's what I'm going to do. We'll talk some about memory, climate data and climate models, how they work. Then we're going to talk about the glass laboratory, the truces in science, how science kind of keeps itself together. And then finally, some climate data controversies and what I'm talking about when I say a siege on truth. Okay, let's see. My clock is, use a different clock. So here's one of many things that climate scientists use as data. the ice core. You've heard about these. So they're drilled out of Antarctica or Greenland, and they go very deep, and they collect data about the atmosphere from the past, and they actually contain bits of the atmosphere from the past. So this is one of the few pieces of very old climate knowledge that comes from direct observation as opposed to proxy measurement. So here you can take a sample of air from 800,000 years ago, because it's trapped there in a bubble in the ice, and measure how much of particular gases is in that bubble. So that's how we get measurements of the past atmosphere. They also have rings, like tree rings, so you can count back, just like a tree, to know exactly how old that piece of ice is. So climate scientists call these things archives. Here are the rings. And they really are archives, because they literally contain bits of the past. They are the history of our climate. So I like to talk about this is not my phrase, but I like this phrase long data, because we talk a lot about big data today. But in the case of climate and climate change, what we actually care about is long data, going back into the past. And more recent data about weather, for example, has been stored in a whole variety of media, starting with written records like these. This is a ship's log, where people just wrote things down by hand, and moving to published books of climate data. This one from 1914, amazing story, because this was one of the first efforts to collect climate data for the whole world. And these people did that from about 500 stations all over the world. And it took 8 to 12 years to collect that data and put it into a book from just 500 stations. It seems unimaginable in the age of the internet, but then that's how things worked. They had to come by mail, by ship. They had to send back for more information. The reports were delayed or got lost, and so on. Then we get the age of punch cards, which actually predates computers. It goes back into the 1920s in the case of weather and climate data stored on punch cards, but that helps enable the computer revolution when it happens, because these cards can be used for weather data processing. And then finally today, we have huge archives of data stored on tape libraries. This is one at the National Center for Atmospheric Research that holds 8 petabytes of data, and it's already full. So there are vast amounts of data in climate science, and they go back into the past. As I said, they always have to be adjusted. So this example these are precipitation gauges in different countries for both solid and liquid precipitation. And what you're seeing here is that at a particular moment in time, here between these 2 years, a wind shield was added to this precipitation gauge. And all of a sudden, well, not really a sudden, over a space of, 14 years, the measurement changed in a sort of stepwise fashion, because the shield is now changing what the instrument does. It's not changing how much precipitation there is. It's just changing the characteristics of the instrument. So if you know about that change, you can correct for it, because you know what they used to read, and you know how the effect of the windshield on the instrument. So you then can adjust the past data to fit with the present data. They call this homogenizing data. Here's another example. So you can measure snow cover from satellites, but not very precisely, at least at the time satellites first started. They're taking pictures of large areas, huge areas. And to measure the snow cover, they have to figure out which parts of it are white and which parts of it are, say, green or black or gray, because those would be rock or trees. And you want to exclude those from the snow cover. So they divide up the whole image into a set of grid squares, and they use some percentage of the grid square as a yes-no variable. So say 70% of the grid square is white, we're going to call that snow. 90% of it is dark, we're going to not call that snow. And then they put all the grid squares together and average it out, and that tells you the snow cover. So over time, the people who did these measurements used different algorithms to do that processing. And then here in the, around 1990, they took all the old data and reprocessed them with the same algorithm, so that now they're measuring it all in a uniform way. And the dashed line is what they had before. The solid line is what they have now with the same algorithm. Doesn't really matter what the changes were. What matters is the homogeneity of the process. So this record is a better record of what happened in the past than the ones that were put out year by year. My last example, much more recent, this is from 2015. The National Climate Archives put out some new corrections to weather data, and they show you here that they've made some small corrections. You can see they're very minimal. Here's a bigger one, but mostly they're pretty similar to the old ones. And they show you down here what the data would be like if they had not done the corrections. So these adjustments are very significant back here from 1880 until about 1940. And they're using more or less the same corrections here as here, but you see that there's really significant adjustment going on to these data. Okay. Now let's talk about truces. So what's a truce? If we look up the word truce on the Google image searcher, you get a lot of pictures of, here's a white flag, here's people shaking hands, mostly people shaking hands, and here's maybe a different kind of truce, but people sort of coming together to stop fighting, right? We all know about that. Now let's look at a different word, truth. If we look this word up on the image searcher, we just get words. Now here's the thing. These words are actually the same word, etymologically speaking. So in Middle English, true is the singular form of truce. True is the singular form of truce. I think that's fascinating in itself, but I think it really matters for the situation that we're about to talk about. Because all science, as I said earlier, depends on truces. We stop arguing about something and we just work. We adopt a routine and we stick with it, right? Let's look a little bit more at this. So what to be true meant in the Middle English is to be faithful, to be loyal, to be true to someone, to be true to a promise. And that's where the truce aspect comes in, because we make an agreement and we stay true to it. So we have truths. We have truths. So if you look up the meaning of true in the OED, the first meaning that comes up is to be loyal, to be trustworthy, and things like that. So to support and respect a leader, a country, a cause, be faithful to one's word. So that to be true to one's word is what this first meaning is. And only later do we get, the meaning that we often use today, to be true to reality, to be a fact. Okay, what does this have to do with science? Well, I like to talk about this in terms of one of the main features of science as a form of knowledge, which is that it is in principle, something that is done in public. That is, it's not just me doing an experiment in a little bubble and then telling you, here's the result, and you just accept it. It's having others also see that result happen And in the early days of science, the classic illustration of this is the Royal Society of London, where they have a big arena, as it were, and experiments are performed on a stage in front of an audience. So these people who observe the experiment can all testify that, yes, we all saw the same thing. And the modern version of that is something quite different, but it's really, in a lot of ways, the same thing. Let's see, let me get this all out. It's publication, which literally means to make public, right? So you do an experiment or you collect some data and you make them public. And one of the things that you do there is provide a description of how you reached your result. That's the methods section of every scientific article. Now, methods sections never really tell you enough to reproduce a result, but they are at least a stab at that. And it comes from this older tradition of witnessing in person and transforms it into what people, Chapin and Schaffer, called virtual witnessing. So now we witness just by reading about what they said they did. In that world, where you do this, where you publish things, in the distant world of the 20th century, 19 years ago, your data and any models you made belong to you. They're intellectual work product. And you might, if you publish data, what you actually publish is not the long, long table of every measurement you took, but the graph that shows a synthesis of all those data, or something similar to that. Similarly, with models, people almost never actually published computer code in the past. They would just describe an algorithm, and the coding was left to them. And in fact, people would resist very strongly giving up their computer code because, again, that's work product. That's my special thing that I contribute. So when peer review comes in, peer review is also a form of virtual witnessing. And the peers almost never actually review data or models directly. They review the synthesis of it, they review the algorithm, but they don't review all the details of how the result is reached. That has all changed in the last 20 years. So today, it's much more common for people to publish their data and publish their code, and many journals actually require that you do that. So another question here is, what is peer review? Who counts as a peer? So remember I said, in principle, it's public. In principle. But the first peers were people like that. They were English gentlemen, and they had to be gentlemen. They were not allowed to join the Royal Society unless they were gentlemen, and they were always men. They were considered to be valid observers of experiments because they were gentlemen. And part of what that meant was that they didn't have any stakes in the outcome because they were wealthy. Right? They were also presumed to be intelligent and educated, so servants, women, kind of ordinary people, just not even considered potential peers. Now today, later we get an image more like this, where now we've got a couple of women in the picture, but they're all clearly wearing white coats. They're scientists, and maybe today you will see a little more diversity like that in science. But often it's still white men doing this, and highly educated, highly trained. So it's not literally public in the sense that anyone can comment. It's only other experts who are recognized as peers by this institution of science. We'll come back to that later. Okay. So here's a major truce in science. This is about weather forecasting. This is how the World Weather Forecast System works. We have observing instruments in space, in the air, at sea, on land. They send data to giant computers in a few places all over the world. They crunch all those numbers. They use a simulation model to create a weather forecast, and they send it out to national weather services, who then make their own corrections and adjustments and local forecasts and send it out to you. This was designed in the early 1960s and actually was functioning well before that in other ways. And all through this process, and even now, there are conflicts all the time over standards, the way it should be organized, the kind of technology that should be used, the questions about violation of sovereignty, questions about money, should you pay for these data or not? So there are many, many conflicts going on, and yet it continues to work. In the climate space, here's another example of a truce. The IPCC, Intergovernmental Panel on Climate Change, and full disclosure, I serve on that panel now. I'm working on the 6th assessment report. I've not done this before, but I've been part of it since July. Since last June. IPCC is basically the world consensus body of climate scientists. It started with a few dozen people writing the first report in 1990. This is mandated by the United Nations. It's part of the Framework Convention on Climate Change. So it's not they didn't make this up. They kind of came together because they were asked to do this. And they've done a series of assessments over the last 29 years at this point. And what you see here is a steady increase in certainty about the nature of climate change. So here, we can't tell if it's signal or noise yet, but we will sometime soon. The next three reports go from balance of evidence, suggests a discernible human influence, to new and stronger evidence, to very likely, which means in IPCC language about an 80% plus probability, to extremely likely in the last report, which it has a numerical value in IPCC language. So it means that there is 95% confidence that human activity is responsible for much of the observed warming since the mid-20th century. Not necessarily all, but much of it. Okay, so this is another kind of truce. And now let's talk about some targets. Because as this develops, you start to get resistance. And some of it is genuine skepticism, and some of it is highly motivated reasoning put out there and supported by industries that have stakes in the outcome, notably fossil fuels. So I'm going to go very quickly through this, which is older, but it's an important beginning point. So the hockey stick is a graph of the last 1,000 years of temperature. And what it seemed to show in 1998 when it came out was that the present phase, the last 20, 30 years, are warmer than it has ever been globally in the last 1,000 years. So this guy named Steve MacIntyre, who is a retired Canadian mining engineer with a good head for numbers, he knows his way around a spreadsheet, understands statistics, he did not like this result, and he decided that he would investigate it very deeply. And his idea was, this is not a stupid idea, he would say, if you're a corporation, you have books, and in order to convince your shareholders that you are actually earning money, you need to have your books audited. If the person who audits your books works for you, that's corrupt because they have an incentive to tell you what you want to hear, and the shareholders too. So you get your books audited by an independent auditor who doesn't work for you. So MacIntyre would say, we need to audit climate science. The auditors can't be climate scientists because they have an incentive to sort of promote more climate science, I guess. So he mounts this blog in the early days of blogging, and this became one of the most popular climate-related websites in the world, and still is, in fact. And he then proceeded to challenge the hockey stick graph over and over again and blew this up into a national episode. So he asked for, so Michael Mann was one of the authors of this graph. He asked for Mann's data. Mann said, here's some of it. I'm going to give you the rest on an FTP site. You go get it, do what you want with it. MacIntyre then asked for the source code, and Mann said, no, that's my intellectual work product. We published the algorithm, write your own code. That didn't satisfy MacIntyre, who then went to, took this to the US House subcommittee. It got reviewed by the National Science Foundation, the National Research Council, the AAAS, the National Academy of Sciences, and others. And this controversy is weirdly still going on, even though in a lot of ways this is a settled issue. The National Research Council review, so the red line here is the hockey stick, or a somewhat later version of it, by the same authors. And so here's the last 1,000 years, and we're here in about 2003 or 4 by the time these data stop. And it's showing that clearly there's a lot of error bars here, but at the same time, the temperature rise recently is higher than any point in the last 1,000 years. Now here's the reason that MacIntyre got upset, and they're still upset about this. There was this graph that came from 1965 by an excellent British climatologist named Hubert Lamb. So Lamb had some data from Northern Europe, England, Iceland, a few other places, and 1 or 2 data points in the Southern Hemisphere, but mostly Northern. And he made this graph, which was very rough, that showed there was a period right around this time when it was much warmer, even than the very recent past. And they call that the medieval warm period. This is now known as the Northern Hemisphere medieval climate anomaly because, according to Mann and his group, this was not a global phenomenon, but only a Northern Hemisphere phenomenon. It was real, but just didn't cover the whole globe. So they had more data, and then all these other groups also investigated the same thing and came to more or less similar conclusions, which you can see here. There's some pretty wide variation, but nobody is going up above where Mann and his group saw it. So this idea of the audit of climate science spread, and we began to see a lot of these, some of them by groups, some of them by individuals. These two at the top of the list are kind of the official data centers in the UK and in the US. And here, these 4 people, including 5 people, including a guy named just Chad, have done their own audit of the data. And you can see that they have, they vary somewhat, but the general trend is the same across all of them. And I can show you many more graphs like this that represent these audits of climate data. Now this next case is really one of the most fascinating to me. So this is an entity called surfacestations.org. There's a website constructed by this guy, Anthony Watts, who is a TV meteorologist. Anthony Watts runs a blog called Wattsup with That, which is the most visited climate website on the internet. And if you look up any piece of climate data, you will find Wattsup with That graphs, I guarantee you, within the first 20 or 30 images, often in the first 2 or 3. So these are very widely read and popular. So Watts has decided that the real problem was not actual anthropogenic global warming, but the urban heat island effect. So that means that weather stations used to be out in the country in a place that was just a green field, and then a city got built around them, and now it's asphalt and cars and factories generating heat, and it's causing an artificial rise in temperature. So to test this theory, he enlisted with this website volunteers to take the Weather Service manual for evaluating weather stations and go visit them. And he said, take a camera, write it all down, document it, follow the manual, do exactly what it says, and come back and bring us your results. So this citizen science project eventually surveyed almost all the weather stations in the US Historical Climatology Network. Now here's what they found. And it is, in fact, quite surprising. So here you've got, this is MMTS is the temperature sensor. And here it is next to a parking lot, air conditioning unit, exhaust fans, and a cell phone tower. Not good. Here's another sensor. It's sort of crammed into a box of electronics. There are many, many other examples and photos on the website. And Watts' conclusion was 9 out of 10 stations are reporting biased high temperature. So then they break it down like this. And so the orange and the red are stations that are reading 2 to 5 degrees or more higher than they should be because of this sighting problem, meaning the location of the instruments. Now, if that's true, that's terrible. This is a massive bias in the weather record. Well, the really interesting sequel to this story is that the group that manages the Historical Climatology Network took the data from this survey and checked it. Whoops. So they collected all the data. They're looking at, especially at the 3, 4, and 5 ratings, the high biased ratings. And all these red triangles are places where NOAA itself, the Weather Service, verified that yes, the sighting problems documented by the volunteers were real. So they did a pretty good job, and in fact correspond with NOAA's own measurement of the station. But then it turns out that it doesn't have the effect that Watts wants it to have, because Watts is an active climate change denier. Turns out, first of all, that there was a change in instrumentation, and the new, for some of these stations, not all, and the new instruments had a lower temperature, gave lower temperature readings than the previous instruments. So that already brought it down. But then the other thing that's going on is that NOAA is constantly adjusting data based on what it knows about things like that, what Watts showed. So when they compare these, the good sites, the poor sites, and this black line is the research network of really sort of well-cited stations that have been developed to be the kind of benchmark record, they all look pretty much the same. And in fact, if there's any bias here, it turns out that if there is a bias at all, it's actually negative, not positive. So widespread poor site exposure is real, but the adjustments account for it, and if there's a bias, it's negative. No evidence that the trends are inflated. So the point I'm trying to illustrate here is that in these two cases, we have scientists doing the routines that they do, but the truces that have separated one public from another, the small scientific universe from the much larger public, are being broken down. They're being, people are saying, we're not taking it anymore, we're going to now check. But in these two cases, what happened was basically confirmation of the existing science. All right, my last case here is this. This is the Berkeley Earth Surface Temperature Project. This is an unflattering picture of Richard Muller. I should take that off and give him a less sort of terrifying appearance, because he's a very serious scientist. He's a physicist at Berkeley. And Muller was also skeptical of anthropogenic global warming. So Muller decided that he would check. He was going to make his own global temperature record. And this is a much more ambitious project than Anthony Watts. So they were going to now collect every surface station reading that's ever been made and do their own analysis using their new, independently developed adjustment system. So he recognizes it's got to be adjusted, but we're not going to trust the way it's been done. We're going to do it our own way. And they do it this is very recent, this is since about I think they started in 2009 or 2010. And they have an open methodology, an open data set. They publish their data and their code. You can download the whole thing. Why are they doing this? Well, if you look back at the past, there are lots of different data records. These are all made at different times, so they're using different numbers of instruments and different methods of adjustment. But you see that back here in the 19th century, there's some really big differences. I mean, this difference is as big as the claimed global warming today. So if this were real, it would be a serious issue. But time goes on, and the black line is the most current record at the time this graph was made in 2006. And you see it, out from about 1900, they begin to agree pretty well. But computers have made a big difference across this time period. Those early ones are all done by hand calculation, prone to error, and they can't do a lot of stations because it's just too much math. So they use more and more stations as time goes on, and then here, in 1986, we get the first kind of computer-processed record, and then another one later. It's just a successor to this, same people doing it. But Muller has now quintupled the number of stations that are being, sorry, that's not the right number, is it? It's like a factor of 9 times the number of stations that had ever been used before. So they have a gigantic record. Now, here's the interesting side story. So Watts, remember him? He has said, he's been watching Muller, and he says, this is great. Muller, the skeptic, is checking the data, he's doing his own audit, and he's going to tell us the truth. Now we're going to find out what's really happening. We're going to trust Muller. And Muller is then called up to Congress to testify before the study is published, but after the preliminary results are in. And he gets up on the stand and he says, well, we finished our preliminary results, and guess what? They look pretty much like all the other results. So Muller convinced himself. He's done a sort of weird curve-fitting exercise with carbon dioxide, but he's convinced not only that the warming is real, but the carbon dioxide and other greenhouse gases are causing it. So here's another case where we've got an independent audit challenging the data and the methods that are used by mainstream science, and finding that, in fact, the mainstream scientists have done their job pretty well. All right, now unfortunately we have to come to today. So the phenomenon I've been talking about works like this. It used to be that scientists did their work in public, but really it wasn't in public. It was kind of in a small public space, but most people were just out of it. So it's like the laboratory is out there in the woods, even though it's made of glass. But today, the laboratory, is right in the middle of a huge city, and anyone who wants can look in the window and see what's going on. We publish all our data. We publish all our code. You can download it. You can check it yourself. So much bigger challenge for kind of maintaining the integrity of science in an environment like this. And then lots and lots of other things start to happen. One is that because of the Climategate episode that I didn't talk about, when a lot of email was stolen and released from a climate research unit in England, email came to be seen as a form of metadata. So scientists talking to each other on email about their work certainly is part of the work process, and they're going to say things to each other about, well, we should do this, or we should do that, or no, that's a bad procedure, or we should use this other procedure. And they might say other things too that would be a little less savory. So some of the Climategate emails seem to show that these people were kind of interfering with peer review of skeptical papers and some other kinds of things. And this launched a flood of FOIA requests on climate science institutions. So this is an example. There are many, many others where what will happen is that these kind of denialist groups will FOIA not just once, but many, many times, 100 times or more, some institution and say, we want to see all your email that contains the name Michael Mann, because he's often the villain in this story for them. So this is really a use of, FOIA is not a bad plan. It's a good thing. Freedom of Information Act. This is how we keep an eye on the government. This is a way of keeping things more transparent. But in this case, it's being used in a different mode, which is as a deliberate attack on an institution to slow it down and confuse it, because people have to respond to these requests. It takes time, it takes money and lawyers, and it's very, very complicated. So here is a legal firm, Energy and Environment Legal, that specializes in FOIA requests. And its slogan is free market environmentalism through strategic litigation. I'm not quite sure what that means, but you can see what you can get the hint of what they're doing here just by looking at the list. So they've been sending FOIA to the EPA, the Department of the Interior, and go on down the list, and there are a lot of universities on this list if you follow it down the ladder. With the Trump administration, we've started to see a lot of things that are really very dubious scientifically. One of them is this idea that there should be a red team, blue team kind of cage match on television between scientists who think global warming is happening and that it's caused by people, and scientists who don't. Now that is a recipe for kind of a media event, but is not a recipe for good science. As my colleague Richard Rood said about this, this is more like Heath Ledger's Joker in The Dark Knight, causing disruption, distortion, and chaos, than like taking a testable hypothesis and checking it. We have this theory that has become very popular in some circles that somehow getting a research grant is corrupting, that the real motive of climate scientists is to create more research for themselves so that they can get more grants, and that therefore getting a grant somehow focuses you on, you will find anthropogenic global warming because you're getting the money. Now, I think a lot of what this argument is about is that most people don't understand what a research grant is. They think it's a grant that I am now going to be paid to do something in science. Most research grants are really for graduate students, for instruments, for data analysis, computer time, things that scientists need in order to do their work, not about personally enriching themselves. In fact, that's never part of it. You might get part of your salary from it, but your salary is not going to rise as a result of getting a research grant. So an example of this is what happened at Scott Pruitt's EPA when he was still in there. He said that scientists who advise the EPA can no longer take grants from it. But of course, the scientists who know the most about what the EPA works on are the ones who get grants from the EPA. So he has now actively excluded a whole community. They now have to make a choice. I'm going to try to seek a grant elsewhere and maybe not be able to find it because I'm not working on these very special problems that the EPA works on, or I can be on the advisory board. Same strictures did not apply to industry groups. So, here's the theory in the form of a cartoon. The 95% of climate scientists who agree are just doing it for the money. Now, if you balance this against the amount of money that fossil fuel companies spend on lobbying, there's no contest. Whoops. As soon as Trump came into office, they basically announced that we are just going to reject the whole thing. We're throwing it out. So this is the siege part, and the way the siege is beginning to work is that instead of going after the outputs, as in the past, there have been lots of instances in the past of political entities interfering with the results of climate investigations, trying to make, sort of water them down a little bit when they're finally published. This is different. This is going after the whole institution and after the inputs to climate knowledge. So we're just not going to pay for it. So in each of the last 3 Trump budgets, so there was a 2017, a 2018, and now there's a 2019. In each of these 3 budgets, there's been a proposal for a 37% cut to the climate arm of the National Oceanic and Atmospheric Administration. Now, for weird reasons having to do with negotiating in Congress, none of this has actually happened, but this is what the proposal has been. So if you're NOAA and you are ordered by the, you're part of the executive branch, you're ordered by the government to find 37% of your budget to cut, you have to then present a document, here's what we're going to cut. And here is what they proposed in the 2019 budget summary. And these are, these are sort of bureaucratic documents, but they're really worth reading because you can see what the scientists think about these cuts from reading their description of the cut. So here we are, climate research. They're going to eliminate $48 million in climate research grants. This will reduce funding for cooperative institutes, universities, NOAA laboratories, other partners that advance understanding of the Earth's climate system. And down here, eliminate Arctic research. We're going to cut $5 million from Arctic research. This reduction will terminate Arctic research focused on improvements to sea ice modeling and predictions that support fishermen, commercial shippers, cruise ships, and local communities. So, the people who are writing the budget think this is a terrible idea, and they're telling you that, and there are more examples of this in the budget. I won't bore you with them, but. And then one of the more serious things that would, if it were ever enacted, have a really damaging effect on climate science is eliminating certain satellite missions. Because satellites take a long time to design and then to launch and to calibrate, and they propose to eliminate all 4 of these missions. This is the weirdest one. So this satellite was originally proposed by Al Gore, and it was actually built in the 1990s while Gore was vice president, but then it was mothballed by the George W. Bush administration, so sitting there doing nothing. And then it was launched under Obama. So it's out there in space, and they propose to save $1 million a year, a microscopic fraction of the budget, by canceling the data analysis just for that instrument. There are other instruments on the satellite. They'll still be analyzed, but not this one, because that's Al Gore's satellite. Okay, so the last couple of points, the last thing I'll talk about with respect to the siege just happened on February 20th, so just a few days ago. So this guy, Will Happer, this is an interesting case because Will Happer is a serious physicist. He works at Princeton. He is emeritus. He's almost 80 years old. And he has just been appointed to head this climate panel that will now challenge all existing climate science for the Trump administration. Happer is not a fool, and he's a serious scientist, but his last work on carbon dioxide was in 1982 when he actually wrote a paper projecting serious increase in global warming from carbon dioxide. He's become convinced since then that that's not really happening, that actually carbon dioxide will be a benefit to the planet, we should have more of it. He's not a climate scientist, he's a physicist who works mostly on optics, and he doesn't really understand a lot of the dynamics of climate, but he is still going to be the head of this panel. So we're going to see this play out now. They're really doing this, and this is the equivalent. This was the replacement for the cage match concept. All right, let me sum up here. We used to have a system in which authority and trust came from expertise that was certified by being a professional scientist. These communities were small. They reviewed each other in journals. Their data and models they kept to themselves. Data analysis required a lot of skill and specialized tools that most people could not use even if they had them. And this expertise required a lot of training. Today, we've got a new paradigm coming in which we're not worrying as much about where the authority, what the certification for the authority is. It's based more on messaging and repetition and lots and lots of venues out there. There are journals, there are sort of journals, that are kind of real but not really. There are fake journals, there's fake news, there are blogs. We've got all the data and code out there so people can take them and use them, but maybe not understand what they're using. We have tools for analyzing data and doing statistics that are easily available to anyone. So there are now millions of people who have the skills to run statistical models and digest data and do all kinds of interesting things with it. But again, may lack the understanding of the causal physics of the climate system. But this has not erased the need for extensive training to understand what you're doing. So that piece is still on the table. What's going to happen? I don't know. I think the deep cuts in budgets are not going to materialize because of the House controls the purse strings, and the House is not going to do that. So that's not an issue, but there are going to be other kinds of things, and one of them is just a general diminishment of trust in this science among the public due to efforts like that HAPR panel that's about to be organized. So what's going to happen? Maybe other instruments, agencies, nations will pick up some of the slack. Maybe the private sector will help. Maybe these big tech enterprises like Google or Microsoft, they already have done some work in that space. What's going to happen to the Framework Convention? We don't know. The US has pulled out, but won't be finished with that for another year or so. And then the really big question for me is whether we're going to end up with a new truce in which we really agree to put aside some of these fights and go with facts and reality, or whether we're going to still have kind of divisions based around loyalty to some kind of cause. So I'll stop there. Thanks.
I think there are seats, those of you who are sitting over here up in front. Thank you for that fascinating and unsettling lecture. I think we all came hoping to be unsettled, and you succeeded. And you've agreed to take questions. Thank you so much.
Yeah, please.
So I will direct traffic and call upon those who'd like to ask questions. Yes, please.
Yes, thank you. Thanks so much for fascinating talk. I was looking at the video, the clip that
Yeah.
was there before you started. Is this something that you have done, or that, no?
No, so go ahead.
If we may go back to it,
Mhm.
I noticed that the change in temperature is in the North Pole, is close to the north. It's in the northern hemisphere as opposed to spread throughout the Earth. Especially, it's not. It doesn't occur in the southern hemisphere. So I was wondering if this is reality or is it fiction?
No, that's real, and the reason is that so first of all, there's kind of a climatic dividing line at the equator. The winds go opposite directions, north from the equator and south from the equator, and the southern hemisphere is mostly ocean. So the ocean is a moderating influence on temperature because it holds much more heat and it's much more stable. So we expect to see this at the North Pole, and it's still happening at the South Pole, but there's less of it.
Good observation. We have an empiricist in the group.
Absolutely. Yeah.
Many empiricists. Yes, please.
What might this mean in terms of our ability to specify a valid carbon price?
Well, that's kind of beyond my pay grade, but Well, let's see. So the IPCC report on keeping temperature increase to 1.5 degrees came out in the fall. And basically what it says is that we have to peak emissions in 2030. And then we have to drop rapidly to 0 and actually even below 0. We have to start sucking carbon out of the atmosphere somehow. If we are to achieve a goal like that, it would imply a pretty high price on carbon. You know, no one thought that the 1.5 degree goal was going to be easy to achieve. There's better and better evidence that that would be a really good idea, that 2 degrees is not a, you know, there'll still be some rather catastrophic changes at 2 degrees. So, but we're probably headed there. You know, there's a lot that could happen between now and 2050 to change this. A price on carbon would be one way of doing it, but there are lots of other mechanisms. And I just read yesterday, I haven't followed up on this to find out exactly what happened, but the EU, the head of the EU announced that they would put €1 trillion into the energy transition. 1 out of 4 EU euros for the next few years. So if that's real, that could be a game changer. And China too has done an amazing turn on you know, away from coal and toward renewables and reforestation. And they're still building coal plants, but they canceled hundreds of contracts that were going to go through, and they're building solar at an unbelievable rate. So it's, you know, it is possible. It is a very, very big project, and as long as the US is not on board, it's going to be very hard to sell.
Yes, sir, thanks.
I have a personal anecdote to tell. In the 1970s, I had a section at Bell Telephone Labs, which was on biology. And we had been physicists to begin with. And at that point, Will Hacker was at Columbia in the physics department. And he wanted, I didn't know him at first, and he wanted to learn biology. And so we came to, he asked me to do it, and I said, yes, well, come in. And he came in every Tuesday morning, so he spent half the day there. And he read a textbook on biochemistry. And I said, would you like to talk to us about how the research we're doing, or just physics and biochemistry? He said, well, we'll get around to that, but I first want to get this book straight. It's pretty, you know, what the textbooks in biochemistry look like. So he stayed about 6 months, and he left. And he had something in mind, an experiment in mind, which he eventually was done. Not by him, but he had an idea about how to increase the sensitivity of a nuclear experiment. And it did work. It was not changed the world, but it did work. And it was then abandoned. So he's not, my own experience, and more than one knows about it, he's a knowledgeable scientist, of course.
Yeah.
But inside that glass cage are the individual scientists. And there is a style working in science, with all those things that you can't list on a slide. But they do influence very much. Sort of view one takes the science one does. And that way they influence the conclusion. Will Hacker is a very unusual scientist, and no other scientist I know would have gone about learning how to do biological research the way he did.
Mm-hmm.
Were you all
Okay,
able to
thanks.
hear that? Yes, more or less. Yes, Jane.
Yeah, thank you for the talk. I am interested in your conclusion of your proposals. A lot of them are kind of operating on an organizational level, but I'm sort of interested in the role of individuals in the engagement, because as someone who doesn't have any special knowledge in data analysis and in climate kind of modeling, I can only, like, when you talk about the audits, I only engage it passively by accepting the output. But when you talk about kind of the financial argument between the government and the institutions, it's some kind of argument that we can engage ourselves as general public who have no special knowledge. So I'm just wondering if there is kind of different kind of communication mode between on the individual level rather than on the organizational level.
Yeah, sure. Well, there's a lot to say about that. Here, I'm not going to let me at least get you to different slides.
You can't compete with that.
Yep. Here, we'll just shut this down. I guess it doesn't want to quit. So, communication. This is a big issue because we tend to have. Boy, how do
If you close the laptop over
I tell you what? I'll just disconnect it from the. There we go. Now you can stare at the blue screen instead. So, the language that scientists tend to use is often really opaque, and that's been one of the issues about climate science. So, one of the favorite words of climate scientists, the first word I heard in a lot of interviews when I was starting to do research on this back in the early 1990s, was uncertainty. You know, so they would always say, there's a lot of uncertainty around this, but, and then they'd go on. Well, this is kind of like what my Aikido instructor used to say, never block with your face. This is leading with your weakest point, right? Because of course there's uncertainty. You know, it's science. We don't know everything, and you want to lay that out there. But for a long time, for decades, that was always the leading line. And the thing is that when most people hear that word, what they hear is, I'm not sure, or even, I've got no idea. So it's a fine word for scientists, but it's not a fine word for communication about science. There are lots of similar examples. Greenhouse gases. What does that mean? You know, so a better word would be heat-trapping gases. Uncertainty. What would be better? Range. Because it's not that we don't know anything. It's that we're not sure within some range, which is exactly the right value. And you can list many, many examples like this. So there's been this kind of gap between the scientific communication and the public communication about it. It's starting to be filled in really creative ways, both by the scientists and by professional communicators who work on this and have, so I told the class this earlier that I've got a colleague who's been doing workshops with meteorologists, TV meteorologists, and what she's doing is encouraging them to, every time they talk about a phenomenon like a hurricane or a fire, to say, and here's what the statistics were on fires or hurricanes in this area 30 years ago, and here's how they've changed because of climate change. Just lay it out over and over again. But to do it in the context of things that people pay attention to and that they understand.
So one thing I never understood, I still don't understand it. The vested interests behind climate deniers are global, right? These corporations and so on. The social media that are spreading so much of the new structure that you're talking about is global. Everybody knows. And yet it is the United States of America where this whole virulent thing has happened. And so many other countries, it's like, several decades ago, creationism, right? It was happening here, but no, everybody else looked at us and said, what are you doing with the evolutionary theory? What's that about? Why is it only happening here? And all the other countries of the world are saner than we are.
Yeah, well, unfortunately they're not. And, but it is definitely, yeah. Well, I think the organized politics of it there's a lot to know about this. I mean, so Naomi Oreskes and Eric Conway have a great book called Merchants of Doubt that goes through this whole history of denialism. And the weird and interesting thing is that it actually starts in the 60s with tobacco. So tobacco and cancer. And there the argument was, we don't know enough, maybe tobacco isn't really causing cancer, delay, and then of course later we find out through documents that they knew all along, in fact had done their own science that showed it caused cancer and just covered it up. That's been happening, so they recount that history for tobacco, acid rain, ozone depletion, and climate change. And the strangest thing of all is it's the same people. So you get certain individuals, Fred Zeitz, Fred Singer, half a dozen others, who move serially from one issue to the next and always say the same thing. There's too much uncertainty. And the key to it is that the last line is always, and we can't afford it. So if you see that line, you know you're dealing with somebody who's got a certain kind of perspective on this. And it's always been, so they also work through a series of think tanks that they developed. So Cato Institute, Heartland, George Marshall Institute, there are a few others, that become kind of professional denialists and publish, white papers and things that look very respectable, have a lot of political connections. So it's been built up over a much longer period in this country than elsewhere. And the fossil fuel companies fund a lot of that stuff, but there's also, to a certain degree, a kind of, there's a Cold War influence on it, but among people who think that ultimately, if you try to stop climate change, that's going to be so expensive, and the only way you can do it is with socialism. Seriously, I mean, this is really what they believe, and yeah, all right.
Yes, ma'am.
If many of the people who were denying the toxic effects of tobacco really knew that it was toxic, is it true now that many of the people denying climate change know that it really is happening?
There have been some.
Don't they have children?
That's always my question. Yes, in fact, and there have been some major document dumps in the last 2 or 3 years from ExxonMobil and Shell especially that show that back in the 1970s, these corporations funded their own climate scientists who told them that carbon dioxide was going to be a problem for their product, and they covered it up. So there are lawsuits going on now against those companies for this active denial of something really, really important about the product that they sell. Yeah.
Thank you for a great talk. So if we now have the Audit Society, I hear this term.
Yeah.
We used to have the Risk Society, of course, and I know you've been researching the Cold War. Sorry. And if China is now cutting down on oil and fossil fuel, they're also investing, I think, in a lot of other countries are as well, into nuclear plants, right?
Yeah.
And which is now being positioned as a very green alternative.
Yeah.
But what about risk in terms of public imagination, where nuclear used to be, and now, which was very unlikely, yet if something happened, that would be we all had a sense that would be a complete disaster, and now we have a very different kind of potential disaster, which seems very likely if you listen to science, but kind of unclear still what will happen, who's going to be affected, how long will that take. So this risk element, how do you see that playing into the model?
Yeah, well, I mean, so I'm just expressing my personal view on this, okay? So this is not, I have a lot of knowledge behind this, but I'm not saying this as a scientist. So you're right, nuclear power has been pushed, I mean, really since the 1990s as a green alternative because it's very low carbon. I mean, there is no energy source that is zero carbon, not even wind or solar, because they use carbon in manufacturing and mining and stuff like that. Nuclear is very low carbon, not as low as solar or wind, but still low. Okay. Nuclear power plants are not economical anywhere in the world now, and I just heard this from a Chinese nuclear engineer. But China is still building them because it needs the energy, and the cost is not the object at this point. China can do that because of the nature of its government. That's unlikely to happen here without some real push from government for, the government already insures all nuclear power plants. There's no private insurance company anywhere that ever has or ever will take on nuclear power because of the scale of the accident potential. So governments have to do that. My view about it is that in places that have stable governments and very well-developed technical systems, nuclear power is probably something we need because we are not going to get out of this fast enough with renewables. I mean, the base of renewables is very small, and even though it's growing at an exponential rate now, and it's cheaper than everything else, we're not going to get to 2050 with zero carbon with renewables alone. So a lot of other people say this too. It's very common among the climate scientists I know to say we have to have nuclear to solve this problem. The political reality in this country is that that's almost impossible. You're just not going to get it. And we've seen with Fukushima and 3 Mile Island and Chernobyl that there are these catastrophic accident potentials. Lots of people have ideas for nuclear power plants that are kind of inherently safe, and maybe that can work, and thorium reactors, but it's always, it costs a lot of money, the outcome is not certain, and it's not well supported by the public. So, yeah.
Questions from students? Yes, Jason.
I have a question about the role of truce in your presentation.
Yeah.
So I imagine that this is not the sort of hardest audience that you've ever given this presentation to. And as someone who also teaches on sort of contentious issues, though of a very different kind, I imagine that your talks sort of invite audience members that at a certain point are sort of unwilling to adapt a common language with what you're trying to say. So I was also struck by this presentation being surprisingly easy to follow. I was like, oh wow, I actually know what's going on within my own field. But at what point is there, like in your sort of experience both presenting this data and having to deal with this never-ending discourse of denialism, if there is no possibility for truce, or there is no possibility of bridging the gap between these different languages, like what then do you conceive of as the solution? Because there's no, like you're presenting no possibility of science without truce.
God, I don't know what to say. That the sort of the filter bubble effect is very strong now, and often, what happens is that the audiences that I talk to already agree with me, and there's nothing for me to teach, in a lot of ways. Most of the engagement, sort of negative engagement I get is on the internet when various things I post on Facebook, or sometimes I'm in the news a little bit, and then I'll get some nasty comments. And the most interesting one right now is I have a former colleague from the University of Michigan who's become a Republican politician in New Mexico. And, he posts all kinds of crap about climate change. He doesn't know anything about it. But what I've been trying to do with him is say, look, let's have a truce, basically. Let's, come talk to me about this, and we'll just have a conversation about the facts. And I can show you some articles, I'll show you some graphs. Here's a piece from MIT or whatever that might sway you. Hasn't changed his mind yet, but it's, I really feel like this whole debate is one person at a time. I mean, you have to be in there, and you have to hang in there with them and keep going after them and try to do it in a civil way so that you can have that conversation. But it's it's hard to do.
Yale actually has a program over at Austrian Environmental Studies that actually tracks the opinion.
Yeah, I know those guys. Yeah.
6 Americans.
Yeah. It's
Actually,
great thing.
The bigger picture is not as pessimistic as we
Yeah.
think they are. Actually, in the last 10 years, the public has swung their views toward there's really a serious climate change issue. I don't have the exact percentage, but if you go to Yale program for climate change communications, and they try to also take a very neutral perspective on this. In fact, Tony Lizowitz actually gets on NPR every morning for 90 seconds or something like that. And he actually interviews more Republicans and Democrats, so it doesn't get into this polemic and everybody just shout at each other.
Oh,
And I personally have a very good friend who basically is a very smart guy. One time I talked to him about climate change and all that. Wow, he just sent me this massive amount of email that are like missives about why this climate change, people are all wrong, but there's no global warming going on, and that kind of stuff is because of this different phenomenon. And he's not a scientist by any stretch of the imagination. He's a lawyer, but, so I think the thing we could do is basically just guys, why don't you go take a look and make your own judgment?
Yeah.
Otherwise, the argument will never end. I mean, just basically, these people, they're going to argue with you all day, and then you end up not being friends anymore.
Well, so the statistics from that program are basically that about 10 to 12% of Americans are really hardcore denialists. The rest are somewhere in between. A lot of them are just don't know and don't care, but the large majority, 60+%, think that climate change is happening and think that people are causing it and think the government should do something about it. And that goes for conservatives as well as Democrats. It's higher among Democrats, but it's still a majority of conservatives. And I was saying to John's class earlier that one of the stranger things is that of that 60%, only 30% talk to their friends about it because they think that other conservatives are all denialists. Yeah, and it's it's kind of like that's what happened in Nazi. Yeah, spiral of silence, exactly. Yeah.
Maybe one more student in particular. Yes, please, Sean.
This may be a bit out of the scientific part of your talk, but I'm wondering why do you think that climate change has become such a political issue? It's a class in the 90s, roughly.
Yeah.
Both Democrats and Republicans agreed that are similar opinions, and now it's at least in terms of official rhetoric very different. So why has climate been politicized?
Well, of course, that polarization has also happened with other issues, but the climate change issue is really weird because it's. So in case everybody didn't hear that, so Democrats and Republicans mostly agreed in the mid-1990s, and today there's a huge polarization. So Riley Dunlap, who does a lot of polling in this area, has been doing it for 30 years. He told me that of all the issues that divide left and right, so abortion, gun control, taxes, everything, climate change is the hardest one to move the needle on. And I think part of the answer to your question is that it was done in this very deliberate and professional manner by these think tanks and very well-funded advertising campaigns. I mean, so Naomi has all these slides of ads that were published all over the country in the mid-1990s that just sort of said, is the planet warming? Snow's falling in Tennessee. And things like that over and over and over again. So the strategy of sowing doubt became really mainstreamed and amplified massively in media campaigns. My favorite one of these was, you guys know who Ted Kaczynski was, the Unabomber? Sent mail bombs to people. So Heartland Institute put up a billboard near me when I lived in Michigan, said, do you still believe in global warming? So does Ted Kaczynski. And that kind of went too far even for some of their funders, and they lost some donors after that. But it's very a manipulative media campaign. It's been very effective. Yeah.
So just two brief points before we applaud. Same time, same place. Next week we hear the third Schulman lecture from Wei Hong Bao, University of California, Berkeley, on the cloud of doubt. Be quite different, but also very interesting. And the final thought is Middle English. There's another root for tree, and it's tree. Oh. Think about that. Huh. True trees, because a tree is something which is true and faithful. Huh. So you've got a green meaning in there as well. So please let us.
Okay. Thank you. Thanks so much.